Okay, here we go. So we have another linear modeling problem here. Now, the population of a city was about 170,000 in 1980 and has decreased by about 1,000 per year since then. A, we want to complete this table to help find an expression that stands for the population of this city in thousands at T years since 1980. Show the arithmetic to help see a pattern. In the last part of the problem, B, we want to evaluate the expression that you found in part A for T is equal to 32. Okay, so if you remember, in the last problem we looked at, we said that Y is equal to mx plus b is the big guy, right, in the house that you need to deal with linear modeling problems. And we said that m stands for the slope or the rate of change, right? And your b stands for is your y-intercept, which is described as the starting value, the initial value, the constant, the beginning number, the fixed number. All right, so these are words that are used to describe your y-intercept. So right here, you're going to ask yourself, which of these numbers is the fixed number or the initial number, and which of these values is the rate of change, the rate at which the population of the city is changing. So it says that the population of the city was about, so that was the initial. So right here, 170 becomes your B. And this population is decreasing by about 1,000 per year. Because it is decreasing, that should tell you that the slope is what? Is negative. And this is decreasing by 1,000 per year. So I'll just put 1,000 x. All right. So here is your equation right there. But really, because it says that in terms t years, so we can rewrite this equation as y is equal to a negative 1 t is the same as negative t plus 170. So this is the equation that you can use to complete this table. And this particular equation models how the population of the city is decreasing. Okay, so for instance, at t is equal to 0, that's the starting year, which is 1980. So what you do is when this is 0, you can actually not have negative 0, but that should be it. So that should give you 170. So that is right there. And when t is equal to 1, so we have negative 1 plus 170, and that is 169. And then, and so on and so forth. So you begin to plug in 2, 3, 4. Is that okay? And this is what we have right there. Now, the last part of the problem is that when t is equal to, we want to evaluate when t is equal to 32. So that means that of all what you did, you have negative 32 plus 170, and that becomes, if you subtract 32 from 170, that gives you 138, and this is in thousands. Is that okay? So this is all that you do to solve this problem. Now, some key things that I want to alert your minds to is that when your slope is positive, when you hear increase, that means your slope is positive. When you hear decrease, that means your slope is what? Is negative. And here we had a decreased scenario. So that's why our slope was what? Negative. Okay. So that's all about this problem. Thank you.